Have you ever just stopped and looked up at the night sky when it's really clear?
Oh, yeah.
It's really something. That vastness
Hmm.
makes you wonder, what's out there, what it all means.
Totally. I think that sense of awe and wonder, that curiosity about the cosmos, is something that's been with humans, like, forever.
It really is. And it drives us to do some pretty incredible things. That's actually what we're going to be diving into today, the story behind the launch of the Chandra X-ray Observatory.
One of NASA's great observatories, really a landmark mission.
Absolutely. And we're going beyond just like the basic facts and figures.
Right.
We've got this incredible source for this deep dive. It's actually a firsthand account from someone who was right there in the thick of it.
Oh, wow. A personal perspective on this huge project.
Exactly. It gives us this amazing behind-the-scenes look at what it took to get Chandra up into space. So our mission, if you will, is to really break down the journey of this telescope.
Okay, I like it. So we're tracing its path from like the initial ideas and concepts through all those years of planning and construction and right up to that nail-biting moment of deployment.
Nail biting is right. I mean, we're going to talk about some of those challenges they faced. But ultimately, we really want to get to the heart of the impact Chandra has had on our understanding of the universe.
And it's been up there for a while, hasn't it? It must have tons of data.
Oh, tons. And still going strong. But first, let's kind of zoom out for a second, get a little cosmic perspective. The author of our source material talks about the great gift of astronomy. This idea that it gives us this incredible sense of perspective on where we fit into the grand scheme of things.
It's humbling, isn't it?
Oh, absolutely. Like when you see those mind-blowing images from the James Webb Space Telescope,
Mm.
they're beautiful, but they also kind of highlight how tiny we are in the vastness of space.
It's true. But on the other hand, think about the ingenuity it takes to even build something like James Webb, or Chandra for that matter.
Right.
The fact that we, these tiny beings on this little planet, can create these incredible machines that can peer billions of light years into the past, it's kind of paradoxical. We're insignificant, and yet we're capable of these amazing feats.
It really is. And it
Yeah.
brings us to this idea of mission. The author reflects a lot on what it actually means to be part of something like this, that feeling of contributing to something so much bigger than yourself, where every role, every single task, no matter how small it might seem, is absolutely essential.
Oh, I bet. There's no room for error in a space mission. Every single person on the team, from the engineers to the technicians to the astronauts, has to work together flawlessly.
It's like this intricate, perfectly choreographed dance.
Exactly.
Yeah.
And NASA has so many different types of missions, right? You've got science missions conducting experiments in space, missions exploring new frontiers, astronomical missions like Chandra focused on observing the cosmos, construction missions to build and maintain things like the International Space Station, even missions that are just focused on testing new technologies for future endeavors.
So many different goals. But that sense of shared purpose, of working together to achieve something incredible, it runs through all of them.
It's what binds them together, like a common thread.
So let's talk about Chandra itself. Now, this project, this wasn't something that just happened overnight.
Oh, no, I imagine not. These things take years, decades even.
You're right, decades. Our source mentions that the initial concept for Chandra, for this advanced X-ray telescope, actually goes all the way back to 1976.
Wow, that's even before I was born.
Me too.
Yeah.
It's incredible. And it speaks to the immense amount of long-term planning that goes into these projects. The years of designing and building and testing and refining, all leading up to that moment of launch.
It's remarkable, and it's not just the technology that's evolving over that time. I bet the team working on it changes too.
Oh, definitely. There's this really interesting part where the author describes traveling to Pasadena to actually meet the team behind Chandra. It sounds like it was a really powerful experience for them to connect with the people who had dedicated so much time and energy to making this telescope a reality.
I can imagine. To see the culmination of all that work right there in front of them, and to feel like they were, in a way, completing their part of the mission by getting it ready for launch.
Now, for those of us who aren't like astrophysics experts, what exactly was Chandra designed to do? What kind of stuff is it looking for out there?
So Chandra's main purpose is to detect X-rays. And not just any X-rays. We're talking about X-rays that are emitted from some of the hottest and most energetic objects in the universe. Think exploding stars, super dense neutron stars, and of course, black holes.
So things that are kind of hard to see with regular telescopes.
Exactly. These objects are so hot, millions of degrees, that they emit most of their radiation in the form of X-rays.
Okay. And why is it so important that a telescope like Chandra is actually orbiting Earth? Why can't we just observe these X-rays from down here?
That's a great question. The Earth's atmosphere, thankfully, blocks most X-rays from reaching the surface. It's a good thing for us, in terms of radiation protection, but it makes it pretty difficult to study X-rays from space.
So we need to get above the atmosphere to get a clear view.
Exactly. And Chandra's orbit is quite a bit higher than, say, the space shuttle's orbit, way higher. The shuttle orbited at about 250 miles above Earth, with each orbit taking about 90 minutes.
I remember seeing launches on TV.
Oh, yeah, those were always exciting. But
Why?
Chandra's orbiting much farther out, about 86,000 miles from Earth. Each orbit takes a whopping 55 hours.
Wow, so it's really out there, doing its thing, gathering all that X-ray data.
It is. And, this reminds me of this interesting story the author tells about astronaut Steve Hawley. They were discussing some information in a textbook, and the author realized that some of the details about white dwarf stars were actually outdated. Yeah. It had only been about 10 years since the textbook was published, but in that short time, our understanding of white dwarfs had already changed significantly.
That's incredible. Science is constantly evolving.
It really is. And that's why a powerful new observatory like Chandra was so exciting. It had the potential to make groundbreaking discoveries, to rewrite the textbooks and revolutionize our understanding of the universe.
It's mind-blowing to think about, to be a part of something that could have that kind of impact.
Definitely. But getting Chandra up into space, it wasn't exactly a smooth ride, was it?
Oh, not at all. The author describes this dramatic first launch attempt. Just seconds before liftoff, they had to abort the whole thing.
Abort? What happened?
Well, there was an indication of a hydrogen leak. Just 8 seconds before they were supposed to launch. Can you imagine?
Oh my gosh, those astronauts must have been on the edge of their seats. All that anticipation, and then suddenly.
It must have been incredibly intense. The author talks about how they immediately activated all the emergency procedures. Turns out it was a faulty sensor, not an actual leak.
Oh, wow, so a false alarm. But still, talk about a heart-stopping moment.
But it shows you how seriously they take safety. And it's fascinating how the decision to abort was actually made by one person, Ozzie Fish, who just had this gut feeling that something wasn't right, even though the data wasn't completely clear.
He trusted his instincts.
He did. And you know what? They actually changed the procedures after that incident to reflect his judgment.
That's amazing. It shows that they're willing to learn and adapt even in such a high-stakes environment. They recognize that human expertise and intuition are still so valuable.
And that wasn't the only launch failure scenario they had to prepare for. The author mentions things like a potential main engine failure, or having to perform this crazy maneuver called Return to Launch Site, or RTLS, where they'd have to essentially fly the shuttle back to the launch pad from orbit.
Oh, wow, I hadn't heard of that.
Apparently, it's incredibly risky, especially with a heavy payload like Chandra. But the astronauts train for all sorts of contingencies.
Well, they have to be prepared for anything. Spaceflight is inherently dangerous no matter how much planning goes into it.
Exactly. And as if the hydrogen leak scare wasn't enough, during the second launch attempt, they had to scrub it because of lightning strikes at the launch pad.
Lightning? Seriously?
It sounds crazy, right?
Yeah.
But it just goes to show that you can plan for every technical detail. But sometimes Mother Nature has other plans.
It must have been frustrating for the crew, all these delays.
Oh, definitely. But even with all that pressure and uncertainty, the author talks about the camaraderie and humor that they shared in the crew quarters. There's this funny story about a Fabio cutout that they're using to prank each other.
A Fabio cutout? That's hilarious.
It's nice to see that they could still find ways to laugh and keep spirits up, even when things were so tense. It reminds us that these are real people, with a sense of humor, going through these extraordinary experiences.
It humanizes the whole thing. It's not just about the technology and the procedures, it's about the people behind it all.
But finally, on the third attempt, they were able to launch. But even then, there was a moment shortly after liftoff where an alert tone went off. There was an electrical short affecting the engine controllers.
Oh no, not another problem.
I know. But the crew, they were incredible. They remained calm, assessed the situation, and followed their training perfectly. They had actually practiced this exact scenario in simulations.
Wow, that's amazing. Their training really paid off.
It did. They were able to handle the emergency and continue the mission. It's pretty sobering to think that later on the entire shuttle fleet was actually grounded for a while because of similar issues with wire chafing.
It shows just how many things have to go right for these missions to be successful.
So many interconnected systems.
Yeah.
So much potential for things to go wrong.
And so much at stake.
Right. But once they were safely in orbit, the focus shifted to deploying Chandra. The author describes this as a real point of no return.
That's a powerful way to put it.
It is. They had successfully launched, but now they had to get this incredibly valuable and delicate telescope out there on its own, with no possibility of going back and fixing anything if something went wrong.
It must have been an incredibly tense time.
It was. The deployment sequence was planned down to the second. 7 hours, 17 minutes, and 17 seconds after liftoff. That's when it had to happen.
Talk about pressure. And it's not just the technical procedures, right? The author talks about the importance of self-care during the mission.
Oh, absolutely. The astronauts have to be at their peak, both physically and mentally. They have to deal with things like space adaptation syndrome, which is basically how your body adjusts to being in microgravity.
It's like your inner ear gets all confused, right?
Exactly. It can cause nausea, dizziness, all sorts of unpleasant stuff.
Oh, I bet. Not fun in a tiny spaceship.
Not at all. And of course, there's the psychological stress of being in such a high-stakes environment. So, taking care of themselves, both physically and emotionally, is crucial for mission success.
Makes sense. You can't perform at your best if you're not feeling your best.
Right. So, once they reached that critical time mark, they began the pre-deployment checks, powering up the telescope, checking the inertial upper stage, which is basically a rocket stage that would give Chandra the final boost to its high orbit. All of this is happening while they're in constant communication with mission control.
It's like a carefully choreographed dance with everyone playing their part perfectly.
Exactly. And the author, because they had trained so extensively with the actual hardware, they were intimately familiar with all the control panels and procedures. They knew exactly what to do and when to do it.
It's amazing the level of preparation that goes into these missions.
It really is. And then came the really big moment.
Yeah.
The rotation of the tilt table in the payload bay and the breaking of the umbilicals. Those are the connections that provide power and data to the telescope while it's still attached to the shuttle.
So once those are broken, there's no going back.
No going back. The author describes it as a moment of profound significance, knowing that they were about to sever that physical connection, that lifeline to the shuttle.
It must have been nerve-wracking.
Especially considering that they were about to let go of this $1.6 billion telescope.
Wow. A lot riding on that moment.
A lot. And right before they were given the go for deploy command, there was actually a brief loss of communication with mission control.
Oh, no.
I know. Those few seconds must have felt like an eternity.
In that kind of situation, any little glitch can feel catastrophic.
But thankfully, communication was reestablished and the deployment command was given. The author describes the deployment mechanism as an explosive zipper that releases Chandra and then springs gently push it out of the payload bay.
Wow, what a visual. This incredible piece of technology just floating away into space.
It is. And Eileen Collins, the pilot, she had to maneuver the shuttle very carefully to back away from Chandra. And then the author had this really touching moment where they just said, "Good luck, Chandra," on behalf of everyone who'd worked on the mission.
It's a reminder of the human element behind all of this. All the people who poured their hearts and souls into making this mission a reality.
And it wasn't quite over yet. There was one more crucial step: commanding Chandra's antenna to high power. This would allow it to transmit data back to Earth.
So a seemingly small step, but absolutely essential.
It's often those little details that can make or break a mission.
And it reminds us that attention to detail is paramount in spaceflight.
So Chandra was deployed, but the mission wasn't over for the crew. They still had 4 more days in orbit, and they were packed with other experiments and activities.
Oh, wow. So they weren't just sitting around up there.
No way. They were busy. They had a plant growth experiment. They were testing solar array hinges for the International Space Station, using an ultraviolet telescope, evaluating new high-definition video cameras, even testing out a new treadmill designed for the space station.
It's amazing how much they pack into these missions.
It really is. And there's this great anecdote where Eileen Collins asks Mission Control how her hair is going to look for the post-flight press interview.
Oh, that's funny.
It is. But it also highlights how important it is for these astronauts, these highly visible figures, to be presented in a way that feels authentic and respectful.
Definitely, especially for women and minorities in STEM fields. It's important for them to see themselves represented in these roles.
And one of the most remarkable things about Chandra is its longevity. It was originally designed for a 5-year mission.
5 years? That doesn't seem like a lot for all that work.
I know, but get this. It's still operating today, almost 25 years later.
Wow, that's incredible. It's a testament to the skill of the engineers who designed and built it, and to the dedication of the teams on the ground who are still operating and maintaining it.
The author mentions that the STS-93 crew, the one that launched Chandra, actually has a yearly birthday call with the Chandra ground teams.
Oh, that's nice. It shows the lasting connection they have to this mission. And it highlights the importance of long-term investment in scientific infrastructure. It's not just about the initial launch, it's about the ongoing commitment to keeping these instruments running and producing valuable data.
And Chandra has definitely lived up to its promise. Its impact on our understanding of the universe, especially in the study of black holes and other high-energy phenomena, has been profound.
It really has revolutionized astrophysics. It's given us unprecedented insights into some of the most mysterious objects in the universe.
And it all goes back to that idea we were talking about earlier, the paradox of our own existence.
Right, that we're these tiny, insignificant beings, yet we have the capacity to build these incredible machines that can unravel the secrets of the cosmos.
So, as we wrap up this deep dive, what's your biggest takeaway from the story of Chandra?
For me, it's a reminder that even the most ambitious goals can be achieved with enough dedication and collaboration. The Chandra mission faced so many challenges, technical setbacks, even acts of nature trying to stop them. But the team persevered, they learned from their mistakes, they adapted, and ultimately they succeeded in launching this incredible observatory that has changed our understanding of the universe.
And it's a reminder that there's still so much out there to discover.
Absolutely. And it makes you wonder what other missions, both in space and here on Earth, are happening right now, pushing the boundaries of what we know and what we're capable of.
It's a question worth pondering. And if you're interested in learning more about Chandra, you can check out NASA's website. They have tons of incredible images and information about the discoveries that Chandra has made.
The universe is full of wonders, and we're only just beginning to scratch the surface. Who knows what amazing things we'll discover next?
It's an exciting time to be